Hi, once again, good evening, all.
Good evening, sir.
Okay, so first we will take tree, then some um, then some question according to the tree. Then we will take some periodic question. So let me share my screen. So my screen is visible, right?
Yeah.
Okay, so basically data structure is divided into two parts: linear data structure and non-linear data structure. In linear data structure has data elements arranged in linear or sequential manner such that each member's element is connected to its previous and next elements. And since data elements are sequentially connected, each element traversable through a single run. And linear data structure are like array, stack, queue, and linked list. In array, the data elements are stored at contiguous location in memory, while in linked list, the data elements are not required to be stored at contiguous location in memory. Rather, each element store a link to the location of next elements. In queue, it is a FIFO first in first out data structure. The element that has been inserted first in the queue would be removed first. The insert and removal of the element in this takes place in the same orders. In a stack, it is a LIFO last in first out data structure. The element has been inserted last in the stack would be removed first. The insert and removal of the element in this takes place in reverse order. So basically in linear stack, these are the theory part. You can go through it. If you have any doubt, you can ask. And in nonlinear structure, there are graphs and tree. So let me start with tree. So tree is a nonlinear data structure which is connected and a cyclic graph. So in tree, these are called nodes and these are called edge. These are called node and these are called edge. Right? So these are called node and these are called edge. So if suppose there is one node, only one node, right? There was suppose only one node, then edge will be 0, right? Hello.
Yeah.
If suppose there are two nodes A, B, edge will be 1, right?
Yeah.
Suppose there are three nodes
Two.
edge will be 2, right? Okay, so there is a one important point. A tree with n nodes has n minus 1 edge.
Maximum,
So,
right?
yeah.
Maximum n minus 1 edges. You can be
No,
less
no,
than n minus 1 also.
no. If it is n nodes, then it has n minus 1 edge.
Okay.
You can see if there are node equal to n, edge will be n minus 1. You can see above tree also. If you see this tree, node will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So node is 11. If you see the edge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as will be n minus 1. So everyone got it?
Yes,
Hello?
we
Am I
got it.
audible? Hello?
Yes, sir.
Okay. Okay, so let me remove. Then root of the tree. The node at the top of the tree is called root of the node. In this above tree, this is the root of the node. So root will be a, right? So, and one important point, there is only one root per tree, and there is only one root per tree. So this is the root node. A is the root node. Then parent node. The node which is a predecessor of any node is called the parent node. Like B is the parent node of E, B is the parent node of D, B is the parent node of E, like this. C is the parent node of G, C is the parent node of H, like this. So you can say that B is parent node of D, E, F, like this, and root node is A. Okay, so let's move to the next. Next is child node. A node which is descendant of a node is called child node. Like D, E, F are child node of B. D, E, F, child node of B. G and H are the child node of C. Like this. Then leaf node. A node which does not have any child is called leaf node. Which does not have any child is called leaf node. Like you can see that I, J, K does not have any child node. D also, F also, H also does not have any child node. These are called leaf node of the tree. So leaf node will be D, I, J, K, F, then H. Everyone got it? Root, parent, child, and leaf. Hello.
Yes,
Am I
sir.
audible?
Yes, sir.
Yes,
Yes.
we got it.
It's clear, sir.
Okay, so yeah. So we'll move to the next internal nodes. So the node which has at least one child is called internal nodes. So you can say that B internal nodes, E internal nodes, then C internal nodes, G internal nodes, A internal nodes. So the nodes which is one child. Internal nodes are like A, B, C, E, then G also, right? Then siblings. Nodes having same parents, nodes having the same parents are called siblings. Like D, E, F are the siblings. G and H are the siblings.
I,
So
J.
yeah, I, J are the siblings. So nodes having the same parents. having the same pairs. Like DEF, IJ, like this. Then arity of the tree. Then arity. So arity is defined as number of children of a node is not as arity. Like B has arity 3. So B has number of children is 3, right? 1, 2, 3. So B has arity 3. E has arity 2. So number of children is 2, right? I and J. So E has arity 2. You can see that G has arity 1. Only G has only one child, right? Right. So G has arity 1, like this. If you say A has arity 2, so A has 2 children, B and C. You can say that A has 2 arity. So and then one important points, maximum arity of a node is defined as the arity of the tree. So arity of the tree will be maximum arity of a node is known as arity of the tree. So arity of the tree will be 3, right? You can say that B has arity 3, so maximum arity of a node is 3. So this tree arity will be the 3. So everyone got it? What is arity of the tree?
Yes, sir.
Okay, so can you say that what is this? Suppose this is A, this is B, and this is C. Okay, so D, E, F, and G. What will be the arity of this tree? Can you say?
4.
4.
Yeah, 4. Okay. So, okay. Then levels. So the root node is said to be level 0. And the children is said to be level 1. Right. And their children is said to be level 2. And their children is said to be level 3. Right. Then the height. So maximum level in a tree is defined is called height of the tree. So what will be the height of this tree? Anyone? Maximum level is 3, right?
3. 3.
So height
Yeah.
of the tree will be 3.
3.
So height of the tree is 3, right? Oh, so suppose there is one tree. Suppose this is A. Let's take one example. B, C. So what will be the height of this tree? Anyone?
4. 4.
Yeah. So this is level 0. This is level 1. This is level 2, level 3, and this is level 4. So everyone got it?
Yes, sir. Copy.
Okay. So now we'll discuss binary tree. So a binary tree is a tree where each node can have at most 2 children. Again, I am repeating. Binary tree is tree where each node can have at most 2 children. It can have 0 children also. It can have 1 children also, and at most can be 2 children like this. It can have 0 children also. It can have 1 children also, and it can have 2 children also. Like this. It can have at most 2 children is known as binary of the tree. Binary is known as binary tree. So everyone got it? What is binary tree?
Yes. Yes.
Okay. So yeah. So I'll see one important points. So this is a, suppose this is tree B, C. At level 1, what is the maximum numbers of node at level 0? Sorry, maximum
Sorry, sir?
numbers of node.
One node,
Yeah, one node. At level 1,
two nodes,
No.
two node, right?
Yes, sir.
At level 3,
At most, it will be
at most four.
four. Yeah.
okay, so yeah. At most 4 node, right? At level 3,
Eight.
Eight.
At most eight.
2 cube.
8.
okay, yeah, 8. At level 3, 8, right? So there is one important points. The maximum numbers of node.
2 to the power 8.
Yeah,
2 to the power 3. 8.
this is L. Level, sorry. Is to the power L, right? So everyone got it? Hello? Hello?
Yes, sir. Yes, sir. Yes.
Yeah.
Okay. So what will be the total numbers, maximum numbers of, okay, let's take example. That will be helpful. Suppose there is the height of the tree is 0, right?
Yes.
So total numbers of node is
1.
total numbers
2
of
to
node
the
is
power
One.
0.
1.
1, right?
2 to the power 0.
Okay,
Yeah.
so
Power 0 is equal to 1.
okay, suppose there are two level, height of the tree is 1. Total numbers, maximum total numbers of node possible?
2 to the power 1.
No, I'm considering whole total numbers of maximum numbers of,
To the
2
power.
to the power 2 minus 1.
yeah, so yeah,
2 to the power 0 plus 2 to the power 1.
yeah, so 3, right? If there is height,
Yes, sir. Yes, sir. 3.
so height is 1, then is 3, right? Suppose there is height is 2,
7.
then 7, right? So if you, so total numbers of node, max possible maximum numbers is 2 to the power h plus 1 minus 1, maximum possible total numbers of, right? Everyone got it, this formula? How come?
Yes, sir.
Yes, sir.
Okay, then binary search tree. So binary search tree is a tree which hold the following condition. The value of each node in the left subtree, the value of each node in the left subtree is less than the value of its root, and the value of each node in the right subtree is greater than the value of its root is called if satisfying this condition, then we can say that it is a binary search tree. Suppose this is x, this is y, and this is z. So value of each node is less than the value of its root, and value of each node is greater than the value of its z. If it's
Root
satisfied,
node.
value of its, we can say that this is a binary search tree. So let's take one example. So let's say, is this binary tree? So let's take one by one. Let's check 20, right? So 20, let's check first the left subtree, then we'll check right subtree. So 15 is less than 20 or not? Yes, 15 is less than 20. Then we will check 5. 5 is less than 20. Yes, 5 is less than 20. Then we will check 6. 6 is less than 20. Yes, 6 is less than 20. Okay. Then we'll go to right subtree. 25 is greater than 20. Yes, 25 is greater than 25. So 25 is greater than 20. Yes, 25 is greater than 20. Then we'll check 31. 31 is greater than 20. Yes, 31 is greater than 20. Then we'll check 21. 21 is greater than 20. Yes, 21 is greater than 20. 26 is greater than 20. Yes, 26 is greater than 20. So we can say that this node satisfy BST. Then we will check this node also. 15 is 5 is less than 15. Yes, 5 is less than 5. And 6 is less than 5. Less than 15. Yes, 6 is less than 15. We can say that this node also satisfy BST condition. Then check this node. 5 is 6 is greater than 5. Yes, 6 is greater than 5. Then we can say that this node is satisfy BST condition. We can say that. And 6 also, this node also satisfy BST condition. Let's check this 25. 21 is less than 25. Yes, 21 is less than 25. We can say that 25. We have to check also right subtree. So let's check right subtree. 31 is greater than 25. Yes, 31 is greater than 25. Let's check 26. 26 is greater than 25. Yes, 26 is greater than 25. We can say that this node will also satisfy BST condition. Like this, we have to check all the nodes satisfy BST or not. If it's satisfied, then we can say that this is a binary search tree. So yes, we can say that 31 also satisfy BST condition and 26 also. So this is a binary search tree. So now everyone got it right. If you have any doubt, you can ask in the middle also. Hello, am I audible, right?
Yes, yes, sir.
Yes.
Now how to insert in BST. So let's insert one by one. So 25 insert 25. Then 20 is less than 25, right? So it will be insert in left. 20. Then 39. 39 is greater than 25, right? So 39, let's insert 39 the left, right, sorry. Then 30 is greater than 25 but less than 39, so it will be inserted in the left, right? So 19, it's less than 25, then we'll check 20 less than 20, so it will be inserted in left. And then 45 is greater than 25, right? It is greater than 39, so it will be inserted in right side of 39. Then 55 is greater than 25, then greater than 39, then greater than 45, so it will be inserted in.
Sir, you skipped the 23.
Oh, sorry. So let's insert after the 30. Okay. So 30, 39, then 30, right? Then 23. So 23 is less than 20. Yes, 23 is less than 25, is less than 25. It is greater than 20, right? So it will be inserted into right side of 20. Then 19 less than 25, less than 20. So it will be inserted in left side of 20. Then 45. So 45 is greater than 25, greater than 39. So it will be inserted in right side of 39. Then 55. 55 is greater than 25, greater than 39, greater than 45. So it will be inserted in 55, right side of 45. Then 5 less than 25, less than 20, less than 19. So it will be inserted. So everyone got it how to insert in BST, insertion in BST. Hello.
Yeah, sir.
Yes, sir, got it.
Okay, so let's insert. Okay, so let's insert another. Suppose there are 20, 19, 16, 49, 50, 61, and 30. Let on insert another records. So 1 second. So let's insert first 19. So that 19. 16 is less than 19. Yeah, 16 is less than 19. So 16. Then 49. 49 is greater than 19. So it will be right side of 19, right? Then 50. 50 is greater than 19, greater than 49. So it will be right side of 49, right? Then 61. 61 is greater than 19, greater than 49, and greater than 50. So it will be inside 61. 30 less 30, 90 is greater than 19 but less than 49. So it will be inserted like this. So so everyone got it. Insertion is based.
Yeah, sir, got it.
Okay.
Yes, sir.
Okay. So searching a key in BST. So how to search in BST? Suppose you want to search 21, right? So first it will check 21 equal to 20 or not. When it's root elements, it's not. Then we'll check it's greater than 20 or less than 20. It is 21 is greater than 20, right? So it will go to the
Yeah.
right subtree. But then it will check 25 equal to 21. It is not 20. It is not 25 not equal to 21. Then it will go a left subtree. Then it will check 21 equal to 21. Then it returns element is found. Like this. Suppose if you want to search 26. Suppose you want to find 6, right? So it will check 6 equal to 20 or not. It is not equal to. Then it will check it is less than or greater than. It is less than. So it will go left subtree. Again we'll check 15 is equal to 6 or not. 15 not equal to 6. Then it will check less than or greater than. It is less than, right? So it will go left subtree, right? Then again we'll check 5 equal to 6 or not. It is not equal to 6. Then it will check it is greater than or less than. It is greater than, right? So it will go right. Then it will check 6 equal to 6 or not. Then it is equal to 6. And its element is found. So everyone got is searching a key in BST. How to search?
Yes,
Yeah,
sir.
sir, got it.
Okay. So now we'll solve some questions. So I will be 1 minute. You can answer in the chat box. The question is visible, right? Hello.
Yes, sir.
Well,
You can answer in the chat box. I will wait once. So maximum gives 7. So let's check how many internal nodes are there in the above tree. So internal nodes, what is the definition of internal nodes? Anyone?
Which have at least one child.
Yeah, which have at least one child is called. So you can say that we have at two child. So you can say this is the internal nodes. 3 also have two child. We can say that this is also internal nodes. 4 have two child. We can say that this is also internal nodes. 5 is also internal nodes. 6 is also internal node. 7 also internal node, and 8 also internal. So numbers of internal node will be 1,
7.
2, 3, 4, 5, 6, 7. So total numbers of internal node. Okay, so the RT of the trees. So you have to tell what is the RT of the above tree. So you can answer in the chat box. I will wait 1 minute.
Sir?
Yes.
Sir,
Hello.
the definition of arity is number of children of a node. And here
Uh,
it is asking for trees. So
maximum
so yeah.
maximum children of a node. Sir.
So RT of the tree maximum
number of
RT
children
of
of
a
a
node. Maximum RT of a node
Yeah.
is called RT of the tree.
Hmm.
So yeah, maximum got right answer. So what will be the RT of this node?
2.
Yeah, 2. RT of this node?
2,
2.
RT of this node?
2,
2.
And RT of this node?
2,
2.
This also 2. This is
1,
1, right? 1,
1,
right? This is 1. And this node?
0.
0,
Okay, and this also 0. 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 So RT of that tree will be true, right?
2.
Suppose
Yeah.
there is a one extra node, suppose 20. Then RT of the tree will be
3.
3,
3.
then RT of the tree.
It is not possible, sir, in binary, sir.
Then it will
Yeah.
not be a binary.
Yeah, it is.
Yeah.
So I'm asking above. I'm not telling that this is a binary tree. I'm telling that this is a tree, right? So I'm asking what is the arity of above. So this
Yeah,
is
sir.
okay. Then we have to say what is the height of the above tree. So we can answer in the chat box. So maximum tells 3. So let's check. So this is level 0, right? Level 0. This is level 1. This is level 2. And this is level 3. So height of the tree 3, right? Maximum
Sir.
level in a tree is called height of the tree. So maximum level is 3. So height of the tree will be 3, right? Everyone got it? Hello.
Yeah, sir.
Okay. So now we'll move to the next question. If a tree consists of 16 edges, what is the numbers of nodes? So basically you can answer in the chat box. So and if a tree consists of 16 edges, so if number of node is n numbers of edges equal to n minus 1. So n minus 1 is 16 edges. So n minus 1 equal to 16. Then n will be 16 plus 1. 70, right? So everyone got it? Hello? Hello?
Yes,
Am
sir.
I audible?
Yes, sir. Got it.
Okay. Okay, then next question is what is the maximum numbers of nodes at level 4 of a binary tree? So basically you have to tell what is the maximum numbers of nodes at level 4 of a binary tree. So we can answer in the chat box. Yeah, maximum got right answer. Level 4 binary is 16. So if you see again, I'm repeating this concept. Suppose now numbers of node is sorry at level 0, maximum node possible 1 at level 1, maximum possible 2 to the power 1 equal to 2 at level 3, maximum possible level 2, maximum possible 2 to the power 2 equal to 4 at level 3, maximum possible 2 to the power 3 equal to 8 at level 4, maximum possible 2 to the power 4 equal to 16. So 16 is the right answer. Okay, so we'll move to the next question. If you have any doubt, we can ask. Okay, so we'll move to the next question. If the height of the binary search tree is 4, then what is the maximum numbers of nodes? We can answer in the chat box. Okay, so maximum got right answer. So if there is level 0 means height is, if height is 0, then maximum nodes is to the power 0 plus 1 minus 1 equal to 1. If there is height 1, then maximum node possible to the power 1 plus 1 minus 1 equal to 3. If there is height 3, height 2, sorry, then maximum possible 2 plus 1 minus 1 equal to 7, like this. So if the height of the binary search tree is 4, so 2 to the power 8 plus 1 minus 1, so 2 to the power 4 plus 1 minus 1, that will be 31, right? Okay, so
Sir,
yeah,
what is the difference between this question and previous question?
okay, see, in this question we have asked what are the maximum numbers of nodes at level 4. We have asked at level 4. This is level 0, sorry, this is level 1, this is level 2, level
Oh,
3, and this is level 4. So we have asked maximum numbers of nodes at level 4. So maximum numbers of nodes at level 4. And this question we have asked, if the height of the binary search tree is 4, then what is the maximum numbers of nodes possible? Total numbers of nodes possible. So you got it?
Yeah,
Hello?
sir, got it. Got it, sir.
Yes, sir. Yes.
So next question is, if a binary search tree consists of 8 elements, what is the maximum height possible in above BST? So this question is a bit tricky. We'll wait 2 minutes. After that, we'll discuss. You can answer in the chat box. Okay, so anyone how to approach this question?
Yeah, sir.
Sir, if all the nodes are increasing or decreasing order, then it will be in this case.
Yeah,
Then
yeah. So yeah. So suppose all the suppose nodes like this. Suppose 8 elements, right? So 3, suppose 4 or 2 or 16, 1 2 1 2 3 4, then 21, 5, then 5, or right like this, 7 8. So if you insert in the binary search tree, let's take insert in binary search tree. So you will get 3, then 4, and 2 is less than 3, 16 is greater than 16, then 21, then 5 is 5, then 8, so it will be right. So right, so height is 0, 1, 2, 3, so height is 3, right? So this is not, so if you if elements are increasing or decreasing, or let's, what is the height of the tree? So
Sir,
suppose,
if we take only increasing order, then the maximum height will be 7.
yeah,
No?
yeah,
Increasing or
if
decreasing both can
yeah,
be.
both decreasing, or we will see one by one. If I will take in decreasing order, then I will take in increasing order. So let's take first in increasing order. Suppose 1, 2, 3, then 4, then 5, then 6, then 7, then 8. So let's insert 1 first. So 1, then 2 is greater than 1, right? So 2 is greater than 1, 2 is greater than 1, then 3 is greater than 1, greater than 2, 3, then 4 greater than 1, greater than 2, greater than 3, and greater than 3 also, then 5 greater than 1, greater than 2, greater than 3, greater than 4. So 5 greater than 1, greater than 2, greater than 3, greater than 4, greater than 5. So 6, then 7, then 8, right? So it is level 0, level 1, level 2, 3, level 4, level 5, level 6, and then level 7. If you elements are in decreasing order, so let's take suppose 8, 7, 6, 5, 4, 3, 2, 1. So let's insert one by one. So let's insert 8, then insert 7 is less than 8, then insert 6 less than 7 also, insert 5, insert 4, insert 3, insert 2, and insert 1. So height will be the 0, 1, 2, 3, 4, 5, 6, 7, right? So if elements are decreasing or increasing order, then then there will be maximum height. So everyone got this question? Hello?
Yeah, sir, got it.
Okay. So if you have any doubt in this question, in these questions or BST, you can ask. If you have any doubt in tree part also or anything, so you can ask. Okay. Anjana, can you take peer deck question?
Yeah, sure. Thank you, Sabine. So my screen is visible, right?
Yes.
Yeah, that's easy.
Okay, I'll share the link. I've also shared the code in the chat box. So it requests all of you to go through, click on the link. Yeah, we'll wait for some time for all of you to join. Okay, so we'll start the class now. So the first question is, which linear data structure stores data elements at non-contiguous memory locations? So we'll wait for, okay, so we have already got 7 responses. Others, you all can also respond. Okay. So so someone in the chat box have answered array. Sandeep Kumar, can you please unmute yourself and tell why array stores data elements at non-contiguous memory locations? So array actually stores data elements at contiguous memory locations. So what contiguous memory location basically means, like storing the data elements sequential or in a continuous memory location. So the correct answer is linked list. So, okay. Any doubt in this question? Anyone? Okay. So we'll move to the next question. So in which type of linear data structure is random access possible? So you all can go ahead and answer. We'll wait for some time. Okay, so we have got 9 responses. So let's check the responses. Array. So the answer is array. So can anybody unmute and explain why? Anyone?
The array is indexed. So if we know which index
Element.
we need to access, which element we need to access, we can directly give that index and access that element.
Is it just me, or is your voice, the pitch is not high? I can't hear you. I'm sorry.
One second.
Yeah.
I'm trying to say that arrays are they are indexed, and every element has some index associated with it.
Yeah.
So whenever we want to access a particular index, we just need to give the index value, and
Yeah.
we can access that element.
Yeah, that's right. Yeah. So that is why array is a linear data structure which allows random access. So any doubt in this question, anyone? Okay. So we'll move to the next question then. So it says, which of the following statements are true about binary search tree? So since previously we have discussed about binary search tree, so I hope this question will be quite easy for all of you. So we'll wait for a few minutes. we have got 7 responses. So you've all got the correct answers. That is, the left subtree will always have the value less than that of its root, and the right subtree will have the value greater than that of its root. So anyone, any doubt in this particular question? Anyone? So we'll move to next question then. That is, when removing an element from the end of a linked list, which node should be known? So which among these nodes should be known? You should answer that. So we'll wait for a few minutes for all of you to answer. Okay, so we have got 9 responses. So B, okay. The one who have answered B, that is the node after the first node, can you please unmute and tell why it is the node after the first node? Like we have to remove an element from the end of a linked list, right? So why is it mandatory to know the node after the first node? Okay. So the node before the last node is the correct answer. So anyone, any doubt in this question?
How can you explain once?
Like, look, in linked list, what happens is a particular node will have the element along with the address of the next node, right? You are aware of it, right? Hello, am I audible?
Yeah, ma'am. You are-
Yeah, so you are aware of that, right? Like one particular node will contain the element along with the address of the next node.
Yes, ma'am.
Yeah, you're aware of it, right? So
Yes,
what
ma'am.
happens, like when we have to find, when we have to remove a particular element from the end of a linked list, so we'll at first search for that particular element, right? So now we have searched that that particular element is at the end of the linked list. So as I mentioned, that every node will consist of the element along with the address of the next node, right? So for that, so to remove that last element, we need to know the node before the last node, right? Because that will contain the address to that particular element.
Okay, ma'am. Okay, got it. Got it.
Yeah. Okay. So, any doubt in this question? Anyone? Okay. So we'll move to the next question then. So, which among the following data structures does not follow the referential mechanism of computer organization? So, please go ahead and answer.
Ma'am, the question showing on peer deck is different.
different. Yeah.
Okay.
Yeah,
Just
the
a minute.
question showing on peer deck is different. It is something different.
Okay. Just a minute. Okay, so whatever question is shown, can you all go ahead and answer? Like, the question is like there are two statements. So the first statement is if there are n nodes in a binary tree, the maximum height of the binary tree is n minus 1. And if a binary, and the next statement is if a binary tree has height h, the maximum number of nodes in the tree will be 2 to the power h plus 1. So can you all go ahead and answer? Okay, so those who have answered, both statements are correct. Can you explain how is the second statement correct? Anyone? So the correct answer is, just a second. So the correct answer is that the statement which says if there are n nodes in a binary tree, the maximum height of the binary tree is n minus 1. This is the correct statement. Okay, and statement number 2 is incorrect. Okay, so
Ma'am,
yeah.
ma'am, how first option is correct?
I guess Subindu have explained it. Like if there are, say for example, as he showed that if there are two nodes, then there will be one edge, right?
Yes, ma'am.
So that is what explained.
No, ma'am, there is written height, no?
Sorry,
Can you show previous question?
Okay, Anjana, can I explain?
yeah, please.
Okay, so let me share my screen.
Ma'am, can you can you show that previous question once? I think I read it wrong. Ma'am, it is saying height, na? So height is the level, na? Maximum
Anjana,
level of.
Anjana, can you show the questions? Can you present the question?
Yeah, just a second, Subindu. Yeah, my screen is visible, right?
Yes, ma'am.
Subindu?
Okay, yeah. So yeah, let me take a screenshot. Okay, so you can stop, Anjana. Let me share my screen. My screen is visible, right?
Yes,
Hello?
sir.
Yes.
Yes, sir, visible.
Okay, 1 minute. Okay, so this question, right?
Yes, ma'am. Yes, sir.
Okay. So first statement is there are n nodes of a binary tree. The maximum height of the binary tree is n minus 1. Suppose let's take one example. Suppose there are two nodes, right? So maximum height possible if you take increasing order 1 or 2. So let's insert ones or then 2. Maximum height possible is level 0 and this is
Level
level 1. So maximum height possible is 1, right?
Yes, sir.
Hello. If suppose there are 3 nodes, let's insert 1, 2 and 3. So 1 then 2.
Okay, sir. Now got it. Sorry.
Okay.
No,
Yeah.
I got it now.
Level 0. Everyone got it?
Yes, sir. Yes, sir.
Yeah.
Okay. The second statement is if a binary tree has height h, the maximum numbers of nodes in the tree will be 2 to the power h plus 1 minus 1, right?
2h plus 1 minus 1.
So this statement is wrong.
Yes.
Okay, so that's why statement 1 is correct and statement 2 is wrong.
2 is wrong. Okay, sir.
Any doubt in this question?
No, sir. It's clear now.
Yeah, Anjana.
Okay. So we'll move to the next question. So you have to choose the correct options among all these statements given. So please go ahead and answer. We'll wait for some time. Okay, so we have got 9 responses. Okay, so Subhendu, would you like to take it?
Can you show the question? Okay, so okay. So yeah. Okay, so answer is, can you show the responses? Yeah, correct answer is 1 and 3, A and C. Anyone can explain why A and 3 is the right answer?
Yes, sir.
Yeah.
So the first statement is saying the maximum number of nodes at level h of a binary tree is 2h. So let's example we are taking a binary tree of 3 levels. So the first topmost level is 0. Then after that there is first level, then second, then 3. So at third level the nodes like after like at first node there is only at first level there is only one node. Then at second we have maximum two nodes, so there is 2 to the power 1. And after that the nodes were 2 to the power at second level we have 2 to the power 4 nodes. Per node can have maximum 2 child, so that's why. And after that at third level we have 2 to the power 3 node, that means 8 nodes. So this is the first, and second is wrong because if we have n nodes then edges will be n minus 1. um, basically we take edges. Edges are those which are connective, which connect two nodes. So let's take an example of two level. Then at let's say at first there is one node, and at zero level there is one node, and at first level there are two nodes, and at second level there are three nodes. So in this whole binary tree there are 3 4 5 6 nodes, and this and edges will be 5. So second is wrong, second option is wrong, and the third one is right. And in fourth, the maximum number of nodes at level h of binary tree is not 2h minus 1, it is so you can take it.
It is 2 to the power h in the option 1. You have right.
Yes. That
Okay, so yeah, very good. Okay, so yeah, so let me explain each experiment. So my screen is visible. Okay, so first experiment is the maximum numbers of node at level is of a binary tree to the power h. So already I've explained, if there is level 0, then numbers of node is 2 to the power 0 equal to 1. There, if there is in level 1, maximum possible is in level 1, maximum possible is 2 to the power 1, right? 2 to the power 1 equal to 2. So in level 3, maximum possible is level 2, sorry, 2 to the power 2 equal to 4, like this. So the maximum numbers of node at level is of a binary tree is 2 to the power h. So this is the correct statement. And the second statement is a tree with n nodes has n plus 1 edge. So we have seen, if there is n nodes, then edge will be n minus 1, right? So you can see there is one node, edge will be 0, right? If there is two node, edge will be 1. So like this. So this statement is wrong. The third statement is a tree with n nodes has n minus 1 edge. So this statement is correct, because we have seen, if there is node 1, then edge will be 0. If there is node 2, edge will be 1. If there is node 3, edge will be 3 minus 1 2. So this statement is correct. The next statement is the maximum numbers of node at level h of a binary tree is 2 to the power h minus 1. This is wrong, because we have seen first statement, the maximum numbers of node at level is of a binary tree is 2 to the power h. So everyone got it, this question?
Yes, I got it.
Okay. So if you have any doubt, you can ask regarding tree, linear data structure, non-linear data structure, regarding activity question or practice question. Any doubt? If you have any doubt, you can ask. So anyone can say that what is the time complexity of searching key in a BST? Anyone can say that what is the time max worst case and best case? Anyone can say that? My screen is visible, right?
I guess the worst case will be O of n.
And best case?
Log of n.
Yeah. So I will explain how host copies the log of O of n and log of n. Okay. So let me let me open my whiteboard. 1 second. So let's take an example. Searching a key in BST. So first we'll discuss worst case, then will be discussed best case. So suppose height of the tree is 8. Height of a tree is size. Worst case. So suppose there are in certain like 15, 14, then 10, and 3 and 2, then 1. Okay. So let's insert into a BST. So 15, let's insert 15, 15, then insert 14. If 14 is less than 15, right? So it will be go into left side, right? Then 10 is less than 15, less than 14. So it will go into left side. Let insert 3. It is less than 15, less than 14, less than 10. It will go into left side 3. Let insert 2, less than 15, less than 14, less than 10, less than 3, like this. And let's insert 1, right? So okay, so if you will search 1, right? So first step, if you want to search a key, 1 is present or not, right? So first you will search 15 is equal to 0 and 15 is equal to 1 or not. It is not equal to 1. Then it's greater than 15 or less than 15. Is less than 15, then it will go left side. Then again compare 14. 14 is equal to 1 or not. It is not equal to 1. Then it will get again left side. Then it will compare it's 10. It is equal to 1 or not. It is not equal to 1. Then again it will it is less than or greater than. It is less than. Again go left side. Then again we'll compare 3 equal to 1 or not. It's not equal to. Then again it is equal to less than equal to 1 or greater than equal to 1. Less than equal to 3 or greater than equal to 3. It's less than equal to 3. It will go left side and it will compare 2 is equal to 1 or not. It is not equal to. then it is compare less than 2 or greater than 2, it is less than, then it is 1 equal to 1, this element is found. If you consider, then this element is found, so height of that is 0, 1, 2, 3, 4 and 5. Number of comparison is 1, 2, 3, 4, 5, 6, right? No. So order of most case would be order of n. Right, everyone got it? Hello. Hello. Am I audible?
Yes,
Yes.
sir.
Okay. And the best case will be, this is the worst case. And the best case. If there is a best case will be if there is a balanced binary tree. So there is balanced binary tree. If there is a balanced binary search tree, suppose let's take one example. So the 15, let insert, then 14, then insert 16, okay. 11, 12, and then 9. And suppose 20, 17, and 21. So in this this is a balanced binary tree, right? So if you search any elements, if you will find order of log n time. If you suppose if you want to find 17, so it will first compare with 15. It is 15 or 15 equal to 70 or not, it is not equal to, and it is greater than or equal less than, it is greater than, it will go left right side. Then compare with 20. 20 is greater less than 17 or greater than 70, it's less than 70, and left side, and 17 equal to 70. So it's in best case you will find order of log n time. So everyone got it? So everyone got it, right? Hello.
Yes, sir.
Okay.
Yes, sir.
So other than this, if you have any doubt, you can ask. Okay, so let me then solve some question in BST. So suppose, let's take one example. So insert 50, 3, 40, 17, 8, 19, 95, 60 in binary search tree. I have to tell what is the height of that tree. You have to tell. So I'll wait few minutes. You can answer in the chat box. You can insert the element in BST, and you can answer in the chat box what will be the height of the tree. Okay, so let insert in BST. So 50. Okay, so 3 is less than 50. Yes, 3 is less than 50. Then 40. 40 is less than 50, but greater than 3. So 40. Then 17 is less than 50. Then greater than 3, but less than 40. So this will be 17. Then 8. So less than 50, greater than 3, less than 40, less than 70. So it will be like this. Then 19, less than 50, greater than 3, less than 40, greater than 70. So 19, then 95, greater than, then 60 is greater than 50, less than 90. So 60 will be like this. So this is level 0. This will be level 1. This will be level 2. This is level 3. And this is level 4. So height of the tree will be 4. So height of this VST is equal to 4. Right? Everyone got it? Hello? Hello, am I audible?
Yes, sir. Got it.
Oh yeah. If you have any doubt, you can ask. Otherwise, we can bind up the session.
এইডি আছে আছে শুভম
Okay, thank you everyone.
Thank you, sir.
Thank you, sir.